Okay, we're going to talk very quickly about how it is that I solve a trigonometric function using algebraic concepts. So, first things first, when you get problems like this, what I want you to take a note of is that you have all of the same trigonometric function in your problem, because that's when you really are going to be able to use your algebraic concepts. So up here, what I want to take a note of is that I have tangent squared x plus 5 tangent x is equal to negative 6. Well, this is very similar to an algebra 1 or an algebra 2 topic, that if I had x squared plus 5x equals negative 6. And actually, as it turns out, I'm going to actually use this method to solve for this. And wherever there's an x, I just need to realize that there's a tangent. So what I'm going to do here is, instead of using an x, I'm going to use something called a u. And what I'm going to do here is I'm going to say let tangent of x be equivalent to the variable u. So when I come over here, what I'm going to do is called u substitution here. So I'm going to say that this is u squared plus 5u equals negative 6. And then from here, what I'm going to do is I'm going to solve for u. And then after the end, when I have my u's, I'm going to plug my tangents back in. So here we go. I have u plus u squared plus 5u, and I'm going to add 6 to both sides, so plus 6 equals 0. Because remember, when you solve for a quadratic, you set it up equal to 0, and you factor or you use the quadratic theorem, the quadratic formula. So in this case here, I have something that is factorable, and it's factorable into u plus 2 and u plus 3, and that's going to be equivalent to 0. So then I can go ahead and I can now say, okay, one factor times another factor, that gives me 0. Well, one of these must be 0. So I can either say that u plus 2 equals 0, or I can say u plus 3 is equivalent to 0. And when I have that, I've got that u is equivalent to negative 2, and I've got u is equivalent to negative 3. And what I'm going to do with this then now is that I'm going to now substitute back in. I'm going to say, okay, well, tangent of x then must be equal to negative 2, and tangent of x must also be equal to negative 3. So how is it that I'm going to find out what the x is? So in this case, well, the x must be equivalent to, so this is basically using the arc tangent. So I would take the arc tangent of both sides. So when you type into your calculator the arc tangent, you get some value. And when you type into the tangent of x, you type in the arc tangent. So you go to your calculator, and you come up here, and on your calculator, it's got the little tangent with the negative 1. And you're going to type in here that you're going to take the arc tangent of negative 2, hit enter, and it gives you this value, which is that x is going to be approximately negative 1.107. Now this answer, you have to understand, is always going to give this answer to you in radians. Okay, so this answer is not in degrees. So again, I'm going to come up here and I'm going to type in the tangent inverse of negative 3, hit enter, and I get the value of that it's also approximately negative 1.249. And these are radians, not degrees. And if I wanted to turn them into degrees, I would just take this negative 1.107, so I could take negative 1.107, and I could multiply it by 180, so I could just delete the, multiply it by 180, hit enter, and divide that, make sure to divide it by pi at the end, and you will get that this answer right here is approximately negative 63.4 degrees. Okay? So if you wanted to turn it back, all you would do is you would do the multiplier. And this one here, the negative, so negative 1.249 times that by 180, hit enter, and then divide it by pi. And you get that this is approximately negative 71.6 degrees. So that's how you would do those problems. So I hope that helps with anything that you're doing on those. Those aren't exact values, but that's how you would solve those problems.